Clean and inexhaustible solar energy is the hope for the future of mankind, but the Earth is affected by the atmosphere, weather, seasons, day and night. The utilization rate of solar energy is not high, so scientists in the 60s of the last century to focus on space, in orbit to build solar power stations. Experts estimate that the same area of solar panels in space can generate more than 100 times the amount of electricity on Earth. How will the electricity produced in space be supplied to Earth? This is the most difficult problem of space solar energy. Scientists have come up with a way to convert it into microwave transmission, and then restore it to electricity after receiving it on Earth. This sounds very science fiction, but in fact, scientists in many countries have begun research, which certainly involves the engineering difficulties of building solar power stations in space, but also to verify the feasibility of space transmission technology. Specifically, it is a power generation system that collects solar energy by setting up a solar power station in Earth orbit and continues to supply electricity to the ground with wireless energy transmission. The planned space-based solar power station will be located 36,000 kilometers from the ground in space and will be unaffected by natural factors such as Earth's day and night, weather, and regional latitude. Space solar power stations are not affected by natural factors such as weather and latitude, and can collect, convert, and utilize solar energy on a large scale. It is not dependent on large power grids and can provide directed power or mobile power to remote, disaster-stricken areas and critical facilities. Space solar energy is efficient, clean, and long-lasting, but due to atmospheric decay, the amount of electricity generated at ground-based solar power stations is always limited. To address these issues, scientists are exploring the possibility of building stations in space and using solar power to transmit it back to Earth. Space power stations in space orbit are huge arrays of solar cells that convert sunlight into electricity, which is transmitted to Earth in the form of microwaves or lasers, and then received and rectified by antennas on the surface, and finally transferred to the power grid. In geosynchronous orbit, the electric power is about 10 to 14 kilowatt. Theoretically speaking, the solar energy potential in space is 8 times higher per square meter than that of solar panels on Earth. In other words, even if the electricity can be lost in the process of multiple conversions, the overall efficiency of space power generation is still considerable. The idea of building large solar power stations in space to solve the global energy supply problem began a century ago. In the context of the time, this idea was destined to become a fantasy. Since then, developed countries, led by the United States, have been working hard to turn the fantasy into reality. However, due to the large scale of the system, technical difficulties, and high construction costs, the world has not been able to build a complete space test power station. However, in the past decade, with the dramatic increase in rocket carrying capacity and the dramatic decrease in photovoltaic manufacturing costs, the time is ripe for human exploration of solar energy in space. 100 years ago, a Russian scientist proposed to build a giant solar power station in space to continuously provide clean energy to the Earth. But this idea was too fanciful. In 1941, the famous science fiction writer Isaac Asimov wrote it into a short story Reasoning, describing a space station capable of collecting solar energy and transmitting energy to the planets through microwaves. 27 years later, American scientist Peter Grassi proposed the construction of a solar power station in space. According to his book Energy from the Sun, its future, a solar power station would be built in space, and then the electrical energy would be converted into electromagnetic energy and transmitted via wireless transmission to a receiving station on the ground, which would then convert the electromagnetic energy back into electrical energy and supply it to the power grid. Grassi's design is a step further than the Russian scientist's idea, which also triggered a wave of research on space solar power stations in various countries. However, due to the huge scale and high cost of space photovoltaic power stations, this idea has not become a reality. A new wave of space solar power exploration occurred after 2000. In February 2001, senior U.S. Senator Robert Smith made a surprising statement during a media interview. Explaining U.S. space policy, he said, "Whoever controls space will control the fate of the planet." Former U.S. Secretary of State Kissinger once made a similar statement: "Whoever controls oil controls all nations, whoever controls food controls mankind, whoever controls money controls the global economy." Robert Smith's words reflect that the future competition between countries will move from the ground to space. A space resources battle is inevitable. 6 years later, the U.S. Pentagon submitted a 75-page study to the National Security Space Office that pointed out that space solar energy could become a new source of energy. If a photovoltaic panel can be placed in space, all problems will be solved. By then, the Earth will be able to receive 100% of the Sun's energy, rather than 70%, because the Sun's radiation to the Earth's energy by the night, cloudy skies, and atmospheric influence, its ability to receive limited. The Pentagon's original intent was to collect energy from space through solar panels installed on giant satellites to provide energy for U.S. military bases on the ground in various locations. Since 2012, with the support of NASA's Innovative Concepts program, Professor John Mankins has proposed the Arbitrary Large-Scale Solar Energy Project. Professor John Mankins proposed the SSPS Alpha, Space Solar Power Station with Phased Array on an Arbitrary Scale, program. Subsequently, the U.S. company NOC and the California Institute of Technology signed a $17.5 million contract for the development of space solar power station technology. Europe has also launched research on space solar power stations since 1998, and has proposed the concept design of Solar Sail Tower, which is planned to be moved to space to deliver clean electricity resources to Europe continuously. The conflict between Russia and Ukraine has led to an intensification of the energy crisis in Europe, and the EU's Solar Tower project is expected to be implemented faster. Japan is not far behind in its research on space solar power stations, and has been conducting extensive research on key technologies for space solar power stations since the 1980s. In addition, Japan has included space solar power generation in its National Development Plan and has proposed a roadmap for the development of commercial space solar power stations by 2050. According to the roadmap, Japan plans to build a space power station with a capacity of 1 billion kilowatts in the Earth's geostationary orbit, about 36,000 kilometers away from the Earth. The solar panel designed by the Japan Aerospace Exploration Agency, JAXA, Research Institute is like two giant mirrors. It has a diameter of 1.25 kilometers and gathers sunlight on it, then transmits the energy to Earth through a microwave transmitter. Nowadays, with the energy shortage and the global climate and environmental problems brought about by traditional fossil energy sources becoming more and more serious, the development of clean energy and renewable energy sources, gradually replacing traditional fossil energy sources, has become a global consensus. The construction of photovoltaic power stations in space to achieve large-scale and stable use of solar energy has become one of the main strategic choices of the world's major science and technology powers to solve future energy and environmental problems. In recent years, the world's exploration of solar energy in space has accelerated significantly, especially the outbreak of the Russian-Ukrainian war has further accelerated this process. The U.S. Air Force Research Laboratory and Northrop Grumman Corporation and other institutions to increase research and development efforts in this field, plans to launch key technology space verification by 2025. According to a NASA release, the U.S. Naval Research Laboratory tested a solar module and power conversion system in space in 2020, a key step toward building a solar power station in space. On May 16, 2020, the U.S. launched an X-37B unmanned space plane, which has since flown for a record-breaking 800 days. As a secret project of the U.S. Air Force, the X-37B unmanned space plane also has an important mission to test the feasibility of capturing solar energy from the universe and returning it to the ground, i.e., building solar power stations in space. On May 28 this year, NASA officially announced that it would relaunch the research of space-based solar energy, i.e. solar power station in space. And according to the World Economic Forum announced in March this year, the British government is considering investing £16 billion for the construction of solar power stations in space. The station will be 1.7 kilometers in diameter, weighing about 2,000 tons, and is scheduled to be completed and put into operation by 2040. The British government believes that the project may help the UK achieve a potential solution of net zero emissions by 2050. In August 2010, 12 academicians and more than 100 experts in Indiana-related fields proposed a roadmap for the development of space solar power stations at a technical seminar on space solar power stations held by the Chinese Academy of Space Technology. In 2014, 16 ministries and commissions, including the Ministry of Industry and Information Technology, the Development and Reform Commission, and the Ministry of Science and Technology, organized more than 130 experts from China to carry out nearly 1 year of demonstration work, and the team finally completed the China Space Power Station Development Plan and Key Technology System Planning Demonstration Report. At the same time, the team proposed the Omega Space Solar Power Station design. Compared with the Alpha design proposed by the United States 2 years ago, it has 3 advantages: reduced control difficulty, reduced heat dissipation pressure, and a power-to-quality ratio, electricity generated per unit mass of the system in the sky, that is about 24% higher. On December 23, 2018, the Space Solar Power Station System project, named Project Sun by Sun, was launched at Xi'an University of Electronic Science and Technology, thus kicking off the challenge of outdoor ground verification of space solar power stations. An article in the China Science Journal in 2021 introduced that, with the support of the relevant national departments, China officially started the research on space solar power stations from the 11th Five-Year Plan. On June 18, 2021, China's first space solar power station experimental base was officially launched in Bishan, Chongqing, with a plan to build a Space 3 gorges at an altitude of 36,000 kilometers from the Earth's surface. The base will focus on space solar power station, wireless microwave energy transfer, and space information network technology demonstration and verification. This verification system breaks through and validates a number of key technologies such as high-efficiency concentrating and photovoltaic conversion, microwave emission and waveform optimization, microwave beam directional measurement and control, microwave reception and rectification, and dexterous mechanical structure design. In September 2021, the Fraser-Nash consultancy released a report at the request of the UK government that concluded, solar power from space is technically feasible, affordable, and could bring significant economic benefits to the UK while supporting net zero emissions. In late August 2022, the European Space Agency also published a space solar study that reached similar conclusions. As a result, in November, the European Space Agency asked its member states to fund a 3-year feasibility study of solar power satellites to explore in detail the commercial viability of such systems. According to the roadmap, China will implement small-scale power generation tests in 2022, increase power generation to megawatt scale around 2030, and have the capability to build gigawatt-class commercial space solar power stations by 2050. At that time, experts have proposed a budget proposal to build this space photovoltaic power station is expected to cost 8 trillion yuan, equivalent to the construction costs of hundreds of Sangxia hydropower station. In 2023, researchers at Caltech announced that their space solar power demonstrator, SSPD-1, had successfully collected sunlight from space, converted it into microwaves, and sent it to a ground receiving station via wireless transmission, successfully converting it into electricity on Earth. In 2023, a Japanese Ministry of Economy, Trade, and Industry, METI, led project combining Kyoto University, JAXA and private companies is planning to launch a small satellite around 2025 to conduct experiments on sending electricity from space to the Earth's surface. The advantages of building solar power stations in space are self-evident. In geosynchronous orbit, solar power stations can generate electricity 24 hours a day, with an average solar energy of about 1,300 watts per square meter, 13 times more than on the ground. In northwest China, a square meter of solar cells generates 0.4 kilowatt-hours, while in Chongqing, where sunlight is less available, it generates only 0.1 kilowatt-hours. However, the challenges are equally great. Compared to the terrestrial environment, the space environment is extremely complex, with strong radiation and huge temperature differences. Some calculations show that the aging rate of solar panels in space is even 7 times faster than on Earth. Due to the huge size of space solar power stations, their installation, construction, and maintenance face huge challenges. For example, an industrial-grade space solar power station weighs thousands of tons and may even cover an area of 10 square kilometers, which is equivalent to 1,400 soccer fields. In addition, space debris is also a major threat to solar panels, while long-range radio transmission technology is still waiting for further breakthroughs. These practical problems mean that space solar power stations are still a long way from commercial development. However, the success of SpaceX, the space exploration technology company founded by Elon Musk, in the commercialization of space may provide a reference for the development of space solar power stations. In particular, SpaceX's breakthrough in rocket recovery technology has not only greatly reduced the cost of rocket launches, but also allowed the dream of commercializing rocket launches to become a reality. On the other hand, if the world is scrambling to build industrial space power stations, how much impact will the high energy and long-term microwave radiation have on the ecology, atmosphere, and biology? This question is one of the issues that must be paid attention to by the global community at the same time.